It's only day 3. Go ahead, say it. I got a response already.
Why aren't we doing interview Wednesday?
What is the negotiation between you and I, or you and your classmates? Interview in exchange for Tuesday night homework, which I did not have 100% on last night. So until next Wednesday. All right, until next Wednesday. I'm sorry, Avery. I'm sorry. I got to follow the rules. Day 3 already, huh? Wow, it seems like we should be on day 10. I'm exhausted already doing this unit. We're going to test, what did we say, next Thursday? Is that what we wrote down, next Thursday? Yes? Okay. One figure we have not talked about yet, and that is a circle. Formula, area formula for a circle. We'll go back and look if you need to. Three, Eva.
Pi times the diameter.
Circumference.
Oh.
Cherry pies are delicious.
Pi times the radius.
Apple pies are too. Good work. Set up number 1 for me. I'm not going to read it to you. And set it up, and then we'll solve it together. Okay. Here's the area. Find the radius. Where'd you put the 95? 22, where'd you put the 95?
In the area.
Darn right you did. 95 equals pi r squared. You got to solve for r. Your first move. How you getting r by itself? First move. 21. Yep, divide by, don't take the square root. You can't do that until r squares by itself. So yes, divide by pi. Let's see how well we know each other. What's going to come out of my mouth next? Thank you. There we go. Don't round. We've been around each other too long, I guess. What am I going to do next year, huh? When everyone leaves. It's be so devastated. So devastated when all you guys leave and move on. No, I will not acknowledge you in the hall either. Oh, hey, Mr. Crowley, how was your summer? I don't know who you are. I was in your 8th period. Nope, no recollection of that. From here? 13?
To do simplified to, what's it called?
Draw it in the air. Go ahead.
I forget what it's called. The square root.
Radical, square root. Yep, take the square root of both sides. Now, I did this on purpose. All right, this wasn't a typo or I forgot something. I did this on purpose because if this happens on the Regents exam, here's the rule. What did I not give you here? No rounding directions. So if there's no rounding directions, sorry, suck it up. We do have to write out the full decimal. Okay, so if you do not see rounding directions on a problem, you got to write it all out. Oh boy, I'm so tired. My wrist is hurting. And also, before we end, square centimeters or just centimeters? Square centimeters or centimeters? Just centimeters. Square centimeters is for the area of a figure. All right. What?
Just a question on the work. Are we allowed to write in 95 divided by pi for the square root instead of that line?
So take the square root of 95 over pi?
Yeah.
Sure. Yeah, that's fine. No big deal. My focus today isn't really on area of a circle. It's on this new vocabulary term here. Everyone, I'm sure, has had a piece of pie or a piece of pizza before. the official mathematical term for that piece of pizza or piece of pie is a sector. Sounds pretty official. All right, hardcore. I know some of you guys think you're hardcore, but you're not. You're in Delmar. Sector. All right, sector. 2 radii and an arc that connects it. 2 radii and an arc that connects it. I want it with you guys today. How do you find the area of a sector? How do you find how much area is in that sector? Well, I'm going to tell you the formula I'm about to give you involves that central angle. And this year, you learned that an angle can be measured in how many different ways? 2. 1 in degrees, 1 in radians. So that's why I'm about to give you 2 formulas, because we never know how that angle is going to be measured. What if it's in degrees? Here's how you find the area of the sector. It's going to look pretty familiar at the beginning. I'm going to challenge you where you've seen this before already this year. If the angle, central angle is in degrees, I do measure of the arc, over 360. Does that look familiar? Where have we seen that before? That's how I started the formula for what? From last unit. That's how I started the what formula? Thank you. Who had it? Serena. Thank you, Serena. Arc length formula. And then I did what? Times pi d. But now I'm on the inside of the circle. So I'm not going to do the circumference. I'm going to do pi r squared, the area. So if my central angle is in degrees, I do the measure of the arc over 360 times area, pi r squared. What if it's in radians, though? Could I convert it and use this formula? You could. We have that background. Or I could go right to the radian formula, which is not that bad at all. 1/2, if you want to find the area of a sector, 1/2 r for radius length squared. And then a good old friend is going to come back. Remember what that was called? Theta, not theta. 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 Not theta. Theta. What would you plug in for theta? The angle, but in what units? Radians. That's the angle in radians. That's where it would go if I have an angle in radians. All right? So two formulas depending on what the central angle is in, degrees or radians. All good? Ready to get some practice here? Every single problem we do on this next page is all Regents problems. All right? You'll see more and more of old Regents questions. These are old Regents questions here using sectors. All right, go ahead, read through and we'll talk. You ready? What's my angle in? What type of units is my angle in? Degrees, so we'll use the area formula for degrees. Okay, here we go. Measure of the arc. 14, yeah. 6, measure of the arc. 60, always equal to its central angle. 60 over 360 times 5. Oh, yeah, buddy. Did anybody take a peek at the answers? It's a multiple choice question. Anybody take a peek at those? Let's do that now. What are they all in? They're all in terms of pi, right? Everyone see it? They're all in terms of pi. So probably our answer should have a pi in it. All right, let's pick up our calculator and figure out the rest. What do I mean by the rest? 60 over 360, right? What do you multiply that by? What's left after I took the pi out? 8 squared, or you could put 64 too. And there it is, 32 over 3. So that's all I do when I leave it in terms of pi. I take the pi out and I multiply everything else. 32 over 3. All right. Probably top 15 question here. Coming up, example 3. Top 15 question of the year. I do have my favorite questions. 4 students who think they're in honors geometry, I just added that in, tried to calculate the area of sector COB. So hey, area COB, sector COB is right here, kids, right? Right here? That area right there. They tried to calculate it. And they did it 4 ways, 4 different ways. 2 are correct, 2 are incorrect. We got to figure out who is, who isn't. Before we do theirs, let's do a period 8 one right now. Let's do a period 8 version. If arc BC is 108, what else is 108? Oh, 14. I get so hyped for nothing. 19. What else is 108? Good. Arc is equal to its central angle. All right, how would period 8 do this? We would say measure of the arc, 108, over 360 times, I know we don't have a radius length, but go, hey, shout out, there we go, radius. What do I got? Give me a radius up here. What do I have? CO. So I could do, I'll do OC instead. OC squared. Oh, pi. All right, I forgot the darn pi. Pi times OC squared. What else could I do instead of OC? AO. Anything else I could use instead? BO. I could use any one of those in the formula. All right, let's check out the 4 honors geometry kids. Amy. Hi, Amy. How's Amy's look? How's her version look? Do we like it or no? Why don't we like it? What's wrong with Amy's version up here? Why don't we like Amy's version? Talk to me. 17. Why don't we like it?
Because BC's not radius.
What is BC?
It's a chord.
It's a chord, yeah. Amy, you are an embarrassment to honors geometry. How about Beth? What do we think? Short for Elizabeth? Bethany? Or just Beth? What are we thinking there first? Short? Nickname? Think it's a nickname or is it actually Beth? Nickname? Elizabeth? Bethany?
I've never heard anyone named Bethany.
I had a Bethany. Like in my first,
I know someone named Bethany.
my first couple years of teaching was Bethany. Yep. And she went by Bethany, not Beth. All right, anyway. How's Beth? Good to go? Looks pretty much like ours, right? The one we chose. Yeah, so she's good. She can stay in honors geometry. Carl? Short for anything? Carlton, okay. Carlos? Probably go by Carlos, though. Carlino? Yeah, that was a good one. Yeah, way to go. It's Carl's all right. If you ever call me that, I will throat punch you. All right? If you ever refer to me as that. All right. Is Carl's all right? Yes? No? Why are we shaking our head yes? Half AB? What's AB? Diameter, so I took half of it. Same thing as the radius, right? So Carl's good. So we know Dex, definitely Dexter.
How is he good? The 3
What's your-
times? I just don't know.
Good. All right, I forgot to go over that. Yeah. You got the issue with the three?
Reducing it? Okay.
Okay, just the simplified version. Good question. I forgot to go over that. Should have went over that. Why is Dex wrong? Mahmood?
Wait, for Carl, wouldn't the 1/2 also get squared?
What's order of operations? Do you do parentheses or exponents first? So I would do what's inside. I would take half of AB first. Okay, half of AB first. What's the deal with Dex? What's he squaring? The diameter. AB. I need to square the radius. So that's why Dex is an embarrassment. So we just left with Beth and Carl. All right, all good? All right, one more sector question, then we're going to get to some of my favorite part of this unit for me here. What if I give you the shaded area, and now I'm looking for angle AOC? Which first, by the way, does it say how we have to leave the angle? Radians or degrees, does it state that? Oh, class choice. What do you want to have our answer in, degrees or radians? Degrees, radians? Majority here. How many degrees do I have? Who wants to leave it in degrees? Radians? Okay, 13-5. That loses. Thanks for not voting, some people. All right, we're going to leave it in degrees then. No big deal. So the area here is 12 pi. So let's get our formula up. Measure over 360 times pi r squared, because we're going to find it in degrees. Where's the 12 pi going now in this formula? 12 pi is going where? 4. Where's the 12 pi going, Griff? Darn right it is. What's going in for the measure of the arc? 16? Yes, thank you. That's what we're trying to find. 360 times, I won't waste anybody's time, 6 squared. This right here is a perfect example why this unit's so tough for us. What do I do now? We can all get to this point, but what the heck do I do now to get x by itself? There's a lot of moves you can make. A lot of moves you can make to get x by itself. You want to start us off? Mahmood? You want to get rid of the 360? Multiply both sides by 360? We can. Can I just do one thing first? What's on both sides that, whether it's now or the 8th step, are going to divide each other out? Pi's. Can we just get rid of them right now? See ya. See ya. Yeah, they're going to divide out. So I guess we'll do it Mahmood's way. We'll get rid of 360, so multiply both sides by 360. 12, well, that's a large number. 12 times 360. Wow. 4,320. We got rid of the 360, so I'm left with x times 6 squared. Next move. Square the x.
I meant 6.
Darn right you did. And hopefully I don't have to ask what you would do next. In degrees, this would be this angle. $120. What's your deal? Question?
No,
Stretching out the guns. All right. Jonathan, you good over there? You looked a little puzzled. Sorry, let me stop. I don't want to. Anybody else got to stretch before I got to move on here? Anybody else want to get it going a little bit? We all good? Don't want to call on somebody else and pull a muscle. We're all good? All right. The math gets intense in here, I know. It's intense. We are probably not going to finish the notes, and that's okay. This is actually what we're going to keep doing tomorrow, too. I love it when I take a figure, take another one, smash them together. Find the area now. All right, we're just going to take 2 or more figures that we're familiar with, smash them together, find the area of what we came out with. Name the 2 figures in this diagram. Name the 2 figures. Oh, 13. 2 figures.
Circle.
What circle? Half a circle plus trapezoid. That's what this figure is. Next up, give me the formulas I'm going to need. Give me the formulas I'm going to need for this one then. If I got a circle and a trap. 9, ready? Half of what? Yes. Dig deep. Trapezoid. Can't rattle you. I'll go with the formulas. Look at the figure. Tell me where I can plug those numbers in, please. Where can I plug into the formula now? Ho, 1 meg. Here we go. Where can I plug in? I got 7, 4, and 10 here. Where are they going? Okay, height 4. Good. So that's where I'm at right now. I still need the radius. Anything you can use on this diagram still to find the radius. And yes, you can assume that 10 is the diameter. 24! How can I find the radius? Which would be, thank you. And now this all becomes calculator. It says nearest foot, so we can use the old pi button, right? We got it, nearest 10. $18.
73 square feet.
Claire, you're better than that. Nearest 10. Not whole number, 10.
Oh, 73.3.
You said it earlier, but now you're leaving it naked.
Square feet.
There you go. And I don't know what happened here. Oh, good. Oh, this next one. All right, here we go. Everyone ready to keep your streak alive and not guess the correct slide next? Here we go.
Every single time.
We cannot keep it together. Yeah, I know.
Here you go. Pinwheel.
I picked pinwheel 5 times.
I know. When we pick 5
I was the minority. It only shows up once every millennia.
Am I missing any other more nominations before we get this one wrong? Pretty confident. In fact, I'm so confident I'm going to go real egotistical here. I'll give you the top 2 choices here that you vote for. And Promethean Man. That's how I still know you. Even giving you that, you're not going to guess it right. All right? That's how cocky I am right now. Here we go. Curtains. No curtains? Star. 3 stars. Shatters. Cubes. Curl. Slide left. Slide right. Drop. Swing. Flip. Pinwheels. Genie. And fade. All right, so I'll give you Promethean Man. What else am I giving you here? Slide right and pinwheels. All right. Just so you know, I'm not cheating. I don't have another slide, so I'll go back to the last one. All right, you're ready. Now you have 3 choices. Slide right. Right, slide right. Yeah, slide right, pinwheels, Promethean Man. No homework. Everyone ready for the suspense? If this bites me, I'm going to be so heated. Pinwheels, slide right, Promethean Man. Ooh, cube. Ooh, oh, close. Like if we just had another vote or 2 for the cube, we'd be sitting on no homework tonight. But the streak continues. Now we think of that because I would, if there was was there like a 4-way tie, I would have said sure, you could have it, but a little too late now, a little too late. And I think instead of trying to force this one in the next 3 minutes, this is where we'll start class off tomorrow with on number 6. All right, we're going to do more of these where we smash them together. Homework, homework. Some of it's in the packet, the rest is in the book again. All right. Sectors. Be working with sectors. Oh, the streak.